This is probably the trickiest question out of the four here. That's why we sort of left it till last here. We're asked to find one point on the curve, y equals 1 over x squared plus 1, such that the tangent at that point passes through the point 6, negative 2. So that 6, negative 2 isn't necessarily a point on our original curve y. It's a point that is probably only going to be on the tangent to the original curve y, and we have to find the point at which we should draw that tangent. So since we're talking about tangents, probably the first thing you're going to think of doing is taking the derivative of our function. So let's take the derivative here. We'll rewrite our function as x squared plus 1 to the power of negative 1, and then use the chain rule to get our derivative here. So we'll bring down the negative 1, we'll have x squared plus 1 to the negative 2, and we'll multiply this by the derivative of that inner function times 2x. So this becomes negative 2x, just putting it back into a quotient form here, x squared plus 1 all squared. So there's our derivative. Now let's remind ourselves, what does this derivative represent? It is telling us the slope of the tangent at some point x. So what do we know about that point x? Well, at any point x, we know that y is going to equal, well, it's going to be given by this function. It's 1 over x squared plus 1. So any point on our original curve can be represented as an ordered pair. So I'll say any point on our curve as the ordered pair x, and our y value is 1 over x squared plus 1. So that's any point on our original function. Let's go back to the tangent that we're looking for. We've got an expression up here for the slope of the tangent at this point x. We've got a point, what we want to get is we want to kind of get another expression for the slope of the tangent. So let's just say, how else can we get slope of the tangent? Well, what kind of a line is our tangent? It's going to be a straight line. So our slope is change in y over change in x. Do we know two y values and two x values that are on our tangent? Well, we know that our tangent goes through the point 6, negative 2, and we know that at the point where our tangent just touches our original function, the coordinate can be represented by this expression that we have just above. Okay, so we know it goes through this point here, and this expression right here is true at the point of tangency. So at the point where the curve, where our tangent meets the original curve. So we can take these 2 points and we can use them to get an expression for the slope. So let's see. Delta y over delta x is going to be, let's see, our delta y, let's do 1 over x squared plus 1 minus negative 2 divided by our change in x is going to be x minus 6. Okay? And this expression is going to be equal to the expression that we got for our derivative, because it also represents the slope of the tangent. So we can have negative 2x over x2 plus 1 squared is equal to, because this represents the slope of the tangent, is equal to this expression that I have right here. we'll just change that to plus 2 over top of x minus 6. So now I want to solve this for x. So how can I solve this thing for x? Well, let's see. We can cross multiply like this. So over here, I'm going to have negative 2x times x minus 6. And if I multiply by x plus 2 over 1, I'm going to get, well, let's see. For this first term, I can cancel out an x squared plus 1. So I'll just have an x squared plus 1 plus 2 times x squared plus 1. Now I can expand both sides here, so negative 2x squared plus 12x must equal x squared plus 1 plus 2, x squared plus 2. And now I can start collecting my like terms here. So let's see, I'm going to have, oh, sorry. That should have been squared there. So I'm going to have to just backtrack a little bit, and I'm going to have to square that. So that's going to be x to the 4th plus 2x squared plus 1. Sorry about that. So another line of expanding here. X squared plus 1 plus 2x to the 4th plus 4x squared plus 2. Now, let's collect all of our like terms and bring them over to one side. So I'll have 0 on this side. Over here, I'll have my 2x to the power 4. I'm going to have 7x squared when I combine this, this, and this. And then I'm going to be left with negative 12x from here and a positive 3 for my two constant terms. Now, I need to solve this somehow, okay, for x, possibly. Remember what the question was asking us for. It is asking us to find one point on this curve that satisfies the given conditions. So I don't need to find all of the x values that satisfy this. I just need to find one point that satisfies this. And the one that I can see that is going to satisfy this is going to be x equals 1. Because if I sub in x equals 1, I'm going to get 0 equals 2 plus 7 minus 2 plus 3, or that 0 equals 0. So, once I've got that solution, I just need to sub this in to my equation for y. Y is going to be 1 squared plus 1 is going to equal 1/2. So that one point that I was looking for is the point 1, 1/2. The tangent to the curve at that point will pass through the point 6, negative 2. And I'm done.